Dimensional analysis is going to become a very important part of our calculations for the future topics that we're going to discuss in class. Dimensional analysis is really just a complicated way of saying unit conversions. So when we're talking about unit conversions, we're going to be talking about this thing called a conversion factor. And a conversion factor would be any two values that represent the same amount of stuff. For example, we know of a lot of different conversion factors. There are 60 minutes in 1 hour. That's a conversion factor. We can use it one way or another. If I had 2 hours and I wanted to find out how many minutes that was, I would simply use the 2 hours that I have and multiply it by 60. Dimensional analysis is a systematic way that we go about converting from one unit to a different unit. So if you were asked the question, how many seconds are there in 1 day? You would start out with the only information given to you, 1 day. The systematic approach that I like to use is called the train track method. And on the train track, everything is made into a fraction. So 1 day is a fraction over just 1 or itself. But the day unit is important. We're going to use day, the unit, in order to cancel out everything that we're looking for. Now, I don't know off the top of my head how many seconds there are in 1 day. But one thing I do know is that there are 24 hours in 1 day. So in order to get the units to cancel, I have to have the same unit on top as I do on bottom. So I'm going to put day on the bottom and hour on top. I know that there are 24 hours in 1 day. Now in placing this here, what I've done is I've put day on top and day on bottom. These two cancel out with each other. Now my unit, if I were to do calculations now, 1 times 24 would be 24. But I don't want to know how many hours there are in a day. I already know that. I want to know how many seconds there are. Well, off the top of my head, I don't know how many seconds there are in 1 hour. However, I do know that 1 hour consists of 60 minutes. Top and bottom are the same. And then I also know that there is 1 minute contains 60 seconds. So the systematic approach takes us to the point where we actually cancel out units and hold off all the math until the very end of the entire question. Now that I've set this whole thing up and I have the unit that I'm looking for, seconds, the one that's asked for in the question, I can go about my calculation. 1 times 24 divided by 1 times 60 divided by 1 times 60 divided by 1. The answer comes out to 86,400 seconds. This next one is an example of a more complicated problem or a complex problem. 60 miles per hour is often abbreviated mph. In reality, what it is 60 miles traveled for every 1 hour of travel. Now in this particular question I'm asked to find feet per second. Now both units need to change. We can't change them both at the same time, so we'll take one at a time. There's a common conversion factor of miles to feet, and 1 mile is equal to 5,280 feet. Now if I were to stop the problem right now, miles would cancel, and we would have the unit on top, feet, over the unit on bottom, hours. Now that's half of what I'm looking for, but I need to go a step further. Now I want to get rid of the unit hour. Hour is currently in the denominator, the bottom of the fraction. In order to get rid of hour, I must place it on the top. I want to find seconds, but I don't know how many seconds there are in an hour. But I do, however, know minutes in an hour. There are 60 minutes in every 1 hour. This gets us closer to where we're going. I still, if I were to stop right now, have feet per minute. Closer, but not quite where we're going. The final step would be to get rid of minutes by placing it on top and by placing seconds on bottom. There are 60 seconds in every 1 minute. Minutes cancel. If I were to stop right now, the units left standing are feet per second, which is the unit that we're looking for in the question. The only thing that's left to do is crunch the numbers. 60 divided by 1 times 5280 divided by 1 times 1 divided by 60 times 1 divided by 60. The answer that you obtain is 88 feet per second. These are a couple examples of dimensional analysis, an important tool when we learn about stoichiometry down the line.